Hello my dear students, welcome to IMS Academy. I hope you are enjoying the sessions on the GATE Score Booster series. Now in the previous session I have discussed about geotechnical problems, but in this session I want to create an awareness on the topics, most important topics where we can expect a question, and I'll give you some specified steps while solving these problems. As part of this first activity, I would like to start here is the earth pressure. First topic I would like to start here is what, sir? Earth pressure. If you want to know the practical application of earth pressure in the design of retaining walls, or if you consider bridge abutments, or if you consider the design of basement walls or sheet piles, the application of earth pressure concept is used. And my dear students, when you are preparing for GATE exam, there are some specified steps where you can solve this problem with these specified steps. So first of all, what are the different types of earth pressures we have? First one we have is the active earth pressure. Second one we have is the passive earth pressure. And the third one we have is the at rest earth pressure. So my dear students, what do you mean by active earth pressure? When the wall movement is away from the backfill, we call the earth pressure as active earth pressure. But let me tell you, my dear students, in the GATE exam, they never ask you to calculate the active earth pressure by usually. They ask you calculate the earth pressure when there is yielding of soil mass due to tension, or they can ask you in passive pressure calculate the earth pressure when the yielding of soil mass is due to compression. If they ask you for at rest pressure, they can ask you calculate the earth pressure when there is no yielding of soil mass. So my dear students, they might not ask you in GATE exam directly calculate active earth pressure, passive earth pressure or at rest pressure. Here yielding of soil mass is due to tension in active earth pressure. Here yielding of soil mass is due to compression. Here there is no yielding of soil mass. Now my dear students, based on these properties, we have different coefficients of earth pressure. Now if you see here, the coefficient of active earth pressure is 1 minus sin phi upon 1 plus sin phi. And passive earth pressure is given by the formula 1 plus sin phi upon 1 minus sin phi. When I talk about at rest pressure, it is 1 minus sin phi, my dear students. Or if you are confused here, you can write Kp is equal to 1 upon Ka. This can also be used. So my dear students, when you are solving the problems on the earth pressure, the first and the foremost point is, the first step I would like to discuss here is the calculation of earth pressure. What, sir? What is the first one we would like to see here? The first one I would like to see here is the calculation of earth pressure. So for calculation of earth pressures, we should identify what are the earth pressures we have. One is the active earth pressure, passive earth pressure and at rest earth pressure. So when I talk about the active earth pressure, here the yielding of soil mass is due to stretching or tensioning. Here the yielding of soil mass is due to compression in passive case. There is no yielding of soil mass, we can say it is K0. And remember, basically, just if you see the mathematical order also, numerator is big for Kp when compared to any other things. So usually if you see mathematically also, you can write here Kp greater than K0 greater than K. Or my dear students, if the wall is moving away, the earth pressure tends to reduce. If the wall is moving towards the backfill, the earth pressure coefficient increases. So here the graph suggests in this way. When the wall movement is away from the backfill, the earth pressure reduces. When the wall movement is towards the backfill, the earth pressure increases. So here we can write it this value as Ka, and here we can write it as K naught, and here we can write it as Kp. Okay. So the first and the foremost step here is what, sir? Calculation of earth pressure. Now, my dear students, when I talk about the second case here, the step 2 is nothing but the calculation of total stress. What's, sir? Calculation of total stress. Now, my dear students, let me tell you one concept. Why do you want to study about the coefficient of earth pressure? Sir, when I calculate coefficient, the calculation of total stress, it is nothing but the vertical stress. But let me tell you, when I talk about the earth pressure, it is nothing but the horizontal stress. What, sir? When I talk about the earth pressure, it is a horizontal stress. Suppose here K is nothing but what, sir? Coefficient of earth pressure. It is the ratio of horizontal stress upon vertical stress. Here horizontal stress can be written as K into sigma V. So here you have to understand, my dear students, to convert the vertical stress into a horizontal component, we are multiplying with a coefficient called coefficient of earth pressure. Suppose you can see here, if this is the resultant here, F, you will be making as F cos theta. You are multiplying with cos theta to make the resultant as horizontal. You will multiply with F with sin theta to make it a vertical stress. So similarly, my dear students, here we are multiplying with a coefficient K to convert the vertical stress to a horizontal stress. Now, my dear students, how do we calculate the calculation of total stress? When I talk about the total stress, we have different peculiar cases, like we have different cases here. If I talk about this one, okay. Now, my dear students, here, please observe this. If I consider here the depth of the soil stratum is Z, and gamma is what, sir? Gamma is the unit weight. The vertical stress is always due to the self weight. So here, if you see in stress distribution, it is due to the applied load. Here it is due to the self weight. Here vertical stress can be taken as gamma into Z. So here the second step here is gamma into Z. Now in this same problem, if you have a surcharge loading, okay, if you have a surcharge loading, my dear students, in case of surcharge loading, let me go to the, if you have a surcharge loading, you can say in case of surcharge loading, the stress is uniform. The stress is uniform. So in this case, this will be equal to Q. Okay. Now, my dear students, let me tell you one important case in earth pressure. Before telling about this case, let me tell you one important law. What is Pascal's law, sir? Pascal's law states that pore water pressure Pascal's law states that pore water pressure is same in all directions. That means, if you consider the pore water pressure here, the pore water pressure seems to be same in all directions. But let me tell you, my dear students, we are multiplying with a coefficient to convert the vertical stress to horizontal stress, right? In this case, by default, you need not to multiply with K, or you can assume K is equal to 1. Okay. Now, the question arises here is, suppose we have a water table here. Here we have a water table. And we have, this is the depth of the soil, Z. And what is the condition of the soil, my dear students? The condition of the soil here is gamma set. Now, my dear students, when you are solving the problems on earth pressure, whenever water table is present, when you are solving the problems on earth pressure, when water table is present, please write total stress as effective stress plus pore water pressure. What is effective stress, my dear students? It is the stress taken only by the soil particles. So here, in this case, I'll show you here. When water table is present, remember, my dear students, when water table is present, gamma set will be replaced as gamma dash. When water table is present, gamma set will be replaced by what, sir? Gamma dash. So here, this part can be written as gamma dash into Z. And this part can be written as gamma W into Z. Why people will ask me, sir, why can't I take gamma sat into Z? Because if you take total stress, you will multiply the pore water pressure also with coefficient, which you should not do. That is the reason when you calculate the pressure, you should write it as K into sigma dash plus K in, no K, 1 into gamma W into Z. Right, sir? So, why we are solving in this way? You should know that Pascal's law says that pore water pressure is same in all directions. Hence, the total stress should be written as effective stress plus pore water pressure. Agree, my dear students? Here, the pore water should not be multiplied with coefficient of earth pressure. There can be different layers also in total stress. If you consider here, there can be different layers. Here, gamma 1 Z1, gamma 2 Z2. You should know whenever there is no water table, the total stress can be written as, here in this case, it will be equal to gamma 1 Z1. In this case, it will be gamma 2 Z2. Right? So, my dear students, the first step is calculating the coefficient of earth pressure. The second step here is the calculation of total stress. Now, when I tell you in calculation of total stress, let me give you a generic case where we can come across everything in this question. I am just talking about the vertical stress here, my dear students. So, here we have, this is called the surcharge. And remember, here we have a depth Z1 and we have a gamma 1 here, and this is Z2, and here we have gamma set. And remember, my dear students, there is a water table effect. So whenever there is a water table effect, if you see the diagram here, due to surcharge, I am just drawing, it will be same throughout the things. This is Q, Q, Q. Here it can be written as, this value can be written as gamma 1 into Z1. And here, this can be written as gamma dash into Z2, and this is gamma W into Z2, and this is gamma 1 Z1. So what is the stress at bottom? Q plus gamma 1 Z1 plus gamma dash Z2. For only this thing, you have to multiply with coefficient of earth pressure. For water pressure, you should not multiply with coefficient of earth pressure. Any doubts in this, my dear students? Please comment in the comment box. Okay. So, whenever you are solving a problem on earth pressure, try to get a understanding of how to calculate the earth pressure or how to calculate the effective stress or total stress. Now, my dear students, if I talk about the case 3, now if I talk about the earth pressures calculation, here we have the earth pressure formulas. This is the third step. Third step you can do is multiply with the coefficient of earth pressure with the total stress, you will get the earth pressure. But there is a little bit twist when there is a cohesive soil. Now here, my dear students, when I talk about active earth pressure, it is given by the formula Ka into sigma V minus 2C root Ka. Okay. Similarly, passive pressure, it can be written as Kp into sigma V plus 2C root Kp. Okay. So, my dear students, here is the formula for active earth pressure in case of cohesive soils. In case of what, sir? Cohesive soils. This is the formula in case of what, sir? Formula for passive pressure in case of cohesive. If they have not mentioned anything, or dry or sand, anything, if they don't mention anything about cohesion, you can take cohesion as 0. Now, my dear students, there can be one question here. When you draw the earth pressure diagram, if suppose in this layer you got Ka1, in this layer you will get Ka2. Okay. Now, my dear student, here anyhow the top layer will be multiplied with Ka1 and the bottom layer will be multiplied with Ka2. Okay. But at the interface, here at the interface, it will be multiplied by both Ka1, one case 1. In case 2, they will multiply with Ka2. Suppose, my dear students, here, if Ka1 is greater than Ka2, if Ka1 is greater than Ka2, okay, if Ka1 is greater than Ka2, in this case, the diagram will come in this way. What, sir? The Ka1 is greater than Ka2. If Ka1 is less than Ka2, if Ka1 is less than Ka2, then the problem will come in this way. Now, my dear students, at the interface cohesion is also there. Then one case Ka1 you have to take respect to C1. In the second case, you have to take Ka2 and C2. I hope you are clear with the earth pressure. Sir, just go through these 3 steps before going to the next step. Okay. Just go through that things, student. I just want to go through it. I hope you are following, students. Just see the cases over there. Okay. Now, my dear students, when I talk about here, you have known Ka1, Ka2 and all. Next. Remember, the fourth thing is very important. The area of the pressure diagram. What, sir? The area of the pressure diagram is nothing but equal to force. What, sir? The area of the pressure diagram is nothing but what? Force. So, how do you calculate force? Formula here is, you can say integral, area means integral PA dz. dz is the depth of the soil strata. Here, what is the active earth pressure, students? Here it is Ka into sigma V can be written as gamma z minus 2C root Ka dz, right? And this can be taken from 0 to z. Now, my dear students, if I write here, what will be the active force, sir? The active force can be written as of Ka gamma z square minus 2c root Ka z. You know simple integration, my dear students. Integral x power n, if they ask you, this is given as x power n plus 1 upon n plus 1. Okay. Similarly, if they ask you what is passive pressure is given as of Kp gamma z square plus 2c root Kpz. And you can know these formulas if you want. You can know these formulas if you want. Or, my dear students, you can simply write the area of the pressure diagram is nothing but force. And where does this force act, my dear students? The force acts at its centroid. Where does the force act? The force acts at its centroid. So these are the steps where you have to solve. Step 1 is calculation of the coefficient of earth pressure. Step 2 is calculation of the total stress. Step 3 is area of the pressure diagram. Draw the pressure diagram, or you have to know the formulas. Step 4 is the area of the pressure diagram is nothing but the force. And the step 5 is where the force is supposed to act. It is supposed to act at its centroid. I hope you are clear, my dear students. Now, my dear students, there is a concept called tension crack depth. There is a concept called what, sir? Tension crack depth. When I talk about the tension crack depth, what do you mean by tension crack depth? It is the depth at which active pressure is 0. So, my dear students, if you know what is the formula for active pressure, here active pressure is given by the formula Ka into gamma into Zc, tension crack depth, minus 2c root Ka is equal to 0. So, Zc can be written as 2c by gamma root Ka, and which is a very, very important formula. This formula is very, very important, my dear students. The depth of the tension crack, if they ask you, it is given as Zc is equal to 2c by gamma root K. Okay. Now, my dear students, the active force before formation of tension crack. The active force before formation of tension crack is of K gamma z square minus 2c root K. Okay, sir? Into Z. The active force after formation of tension crack is half Ka gamma Z square minus 2c root Ka Z plus 2c square by gamma plus what, sir? 2c square by gamma. Agree, my dear students? Now you can ask me, sir, this is one time asked in GATE exam. The difference in active force before and after formation of tension crack. What, sir? The difference in, this can be asked in any competitive exams also, sir. The difference in active force before, the difference in active force before and after formation of, the difference in active force before and after formation of tension crack is given by the formula what, sir? The difference in active force before and after formation of tension crack is given by the formula 2c square by gamma. What is the formula, sir? This is 2c square by gamma. Now, my dear students, if you know the diagram also, this is minus 2c root k. This is ZC. Okay, sir. Sir, before formation, this is negative. If you want to know before formation of tension crack, you have to find out the trapezoidal area, this area. This is before formation. If you want to find out after formation, whatever there in the yellow, full triangle, this is after formation. Sir, if you know mathematically also, sir, how to remember whether trapezoid or a triangle. Sir, after formation, you are having extra value. So it should be a triangle. Before, it can be a trapezoid. That is how you have to remember. So I hope you are clear how to calculate the tension crack before and after, and what is the difference in active force, right? Now, my dear students, let me so here, my dear students, if you are really interested at GATE coaching about the GATE job notifications, or are you looking for any freeware course, we have GATE 0 fee program, and we will give all the updates in the Telegram group. You can just click on the link on the Telegram group and join it. You'll get all the updates on the job notification along with the daily quizzes and all about the updates on the YouTube also. So, my dear students, let us understand what actually you want to discuss about critical height. What is critical height, my dear students? What do you mean by critical height here, you can ask? Sir, critical height means it is the depth at which active force is 0. It is the depth at which the active force is 0. Okay. Sir, you can also say, when you are telling critical height means it is the depth at which active force is 0, that is fine. But what is the practical application of it? Sir, see, it is the depth up to which, suppose if you are excavating some soil here, it is the depth up to which an excavated soil can withstand without any lateral support. An excavated soil can withstand without any lateral support. That height is called critical height. So, my dear students, what is the formula for active force? Here, when I talk about the active force here, active force is nothing but half Ka gamma hc square minus 2c root Ka into hc is equal to 0. Here hc can be written as 4c by gamma root K. Here hc can be written as what, sir? 4c by gamma root K. Or you can write this value as 2 into zc. Clear, my dear students? So please write down about the critical height. Please, one thing, read about tension crack depth as well as the critical height. Okay. Now, my dear students, now here, let me tell you one important thing. Sir, see, like they can ask you in active pressure, the failure plane angle is, this was asked one time in GATE exam, sir. In active pressure, the failure plane angle is, what is the failure plane angle here? It is 45 degrees plus 5 by 2. Okay. Now, similarly, if I ask you passive pressure, okay, Here the failure plane angle is how much, sir? Here the failure plane angle is how much, sir? It is 45 degrees minus pi by 2. But if they ask you, here my dear students, if they ask you with respect to major plane, then both cases it is 45 degrees plus pi by 2. Okay. So this is the failure plane angle for active pressure, and this is the formula for passive earth pressure. Okay. Here one more thing my dear students, in active earth pressure, they can also tell you wedge means a soil mass. Here you can write wedge moves. Here wedge moves, because they can ask you instead of calculate the earth pressure, they can ask you calculate the earth pressure when the wedge moves downwards. Then also it is active earth pressure. Similarly, in passive earth pressure also they can ask you wedge moves upwards. Sir, all these theories what we have developed until now, these are related to Rankine's theory. Here we have assumed the rank wall is smooth. When we talk wall is rough, then Coulomb's theory will come into picture and we will do with different things. And the last important thing here is in Rankine's theory, students, we have assumed ground surface is planar. And in this case, Ka into Kp will be taken as 1. Okay, this is the standard case. Suppose if the ground surface is inclined. What, sir? If the ground surface is what? It is inclined here. Ka will be taken as cos beta minus root over cos square beta minus cos square phi upon cos beta plus root over cos square beta minus cos square phi. Here this is the formula. Remember my dear students, if it is passive earth pressure, it will this same thing, and here I will tell you in a refer. K, in this case, Ka into Kp will be equal to cos square beta and the ground surface is inclined. So please write down this, student. Okay, if you have any questions, students, please ask me in the chat box. So these are the important things. So let me summarize what we have to do in the earth pressure. First, the coefficient of active earth pressure when the wall moment is away from the backfill or the yielding of soil mass is due to tensioning. Passive earth pressure is the wall moment is towards the backfill or it is the yielding of soil mass is due to compression. When there is no yielding of soil mass, we call it as at rest pressure, and K naught is equal to 1 minus sin phi, Ka is equal to 1 minus sin phi upon 1 plus sin phi, Kp is nothing but 1 upon Ka. Later we calculate the total stress. Then we have given the active pressure formula Ka into sigma V minus 2C root Ka. For passive pressure, it is Kp into sigma V plus 2C root Kp. The area of the pressure diagram is nothing but the active force. And remember, always the force acts at its centroid. The active pressure is 0, then we call it as tension crack depth, which is 2C by gamma root Ka. Active force 0, we call it as critical height, HC, 4C by gamma root Ka. So these are the important things which I would like to tell you related to the earth pressure. Now similarly, my dear students, when you talk about consolidation topic, okay, sir, here what do you mean by consolidation? What do you mean by compaction? What do you mean by compressibility? The removal of water from voids. What's that? The removal of water from voids is nothing but consolidation. And this consolidation process occurs in a long term, under a steady static long term pressure. Whereas compaction is a short term loading, it is the removal of air from the voids. When you remove both air and water, then it is called compressibility. So here when I talk about consolidation, so here the major questions we can expect is delta H. That is called, I don't want to go in detail, I am talking in prospect of the problem solving. Delta H is nothing but settlement. Okay. Now to calculate the settlement here, you should know delta H by H is given by the formula delta E by 1 plus E naught. What, sir? This is the formula which you have to calculate for settlement, and this is the formula from height of solids. Here, what is, let me tell you. Here, if we draw a graph between void ratio and effective stress, more the void ratio, the lesser the effective stress. So it's a decreasing graph. So here we can write this as E naught. Here we can write it as EF. And here we can write it as this value as sigma final here. And here I can write it as sigma initial. Now if I apply a logarithm, this curve will become a straight line. Now here you should understand, students, the slope of E versus effective stress is nothing but Cc. What do you mean by Cc, my dear students? It is nothing but the coefficient of compression index. It is nothing but coefficient of compression index. So if you consider a straight line, y is equal to mx plus c. How do you calculate the slope? M is nothing but equal to y2 minus y1 by x2 minus x1. Here the coefficient of slope is nothing but coefficient of compression index. So Cc can be taken as E naught minus Ef upon log of sigma final upon sigma initial. So from this equation, if you plug in here, delta H can be, what is delta H? We'll discuss about this problem. Delta H is nothing but equal to H into Cc upon 1 plus E naught into log of sigma final, that is what, sir, upon sigma initial. This is the formula for what, sir? The effective stress. So here let me tell you. Now in this problem I have to tell you all the parameters, sir. H into Cc upon 1 plus E naught into log of sigma final upon sigma initial. Now first and foremost point here is, what is H here? What is H, sir? H is nothing but the thickness of clay layer. What, sir? What is H here? H is nothing but the thickness of clay layer. Okay. Got it, sir? Now how do you calculate Cc? Cc is what, sir? Coefficient of compression index. Coefficient of compression index. Sir, here you should understand, usually consolidation happens in clay layer. That is a very, very important point. So when I talk about coefficient of compression index, Cc can be written as 0.009 into liquid limit minus 10 percentile for undisturbed soils. For disturbed soils, it will be 0.07. You can remember this formula. Okay. Now we are done with H, Cc. And what is E naught, sir? E naught is nothing but the initial void ratio. What is E naught? Initial void ratio. Again, in finding this E naught, my dear students, if you are not aware of the properties of soil topics, then it will be a difficult case. Now let us understand how do we calculate the effective stress here. Suppose if I consider this as a footing, okay. Now, my dear students, usually I'm giving you, suppose this is a sandy layer and here we have clay layer. I'm just telling you some example, okay. Remember, sir, always we have to calculate the effective stress. In this case, the center of the clay layer. Where we have to calculate? We have to calculate the center of clay layer. That means, my dear students, here, if you consider here, this is the effective stress here, right? Here, the load distribution usually will be taken as 2:1. 2 vertical, 1 horizontal in a trapezoidal way. So, if you know this value, if this is the width of the footing, B, this value will be taken as, if this is depth is what, sir? If this depth is Z, this value will be taken as how much, sir? Z by 2, because 2 by 1, you can write here, 2 by 1 is equal to Z by X. So, X is equal to how much? Z by 2. Here also, my dear students, this one is also equal to Z by 2. Here Z by 2, here Z by 2. Here what is the load, sir, we have? This is Q. Now what is delta sigma here is Q. Q is what, sir? Load. Stress is nothing but load upon area, L plus J. You can write this, if it is a rectangle, L plus Z into B plus Z. If it is a square, you can write L plus B plus Z whole square. So this is how you calculate delta sigma. So anyhow, effective stress, you know already I have told you. So in this case, final effective stress can be written as initial effective stress plus delta sigma dash. So in this way, if you can follow all these steps, whenever they ask you the problem on settlement, you can easily solve. So please keep this as a note. Okay, my dear students. Next, there is another concept also called MV. What is MV, sir? Volume compressibility. What is MV? We have volume compressibility. So here if they ask you what is volume compressibility, here is MV is equal to delta V by V into delta sigma dash, or that can also be written as delta H by H into delta sigma dash. Agree, my dear students? Now here delta H is nothing but what, sir? Settlement. Here delta H can be written as MV into H into delta sigma dash. Delta sigma dash is nothing but the overburden pressure. This is the second way how to solve the problem related to settlement. Now, in this process, they can ask you, they can give you coefficient of compressibility and they will ask you how to calculate MV. So here if they ask you coefficient of compressibility, the coefficient of compressibility is given by the formula. The coefficient of compressibility is given by the formula here. Please understand, students. What is the coefficient of compressibility? This is nothing but AV. AV is equal to what, sir? Delta E upon delta sigma dash. Clear? That is change in void ratio to change in effective stress. And remember, you can write here mv is equal to av upon 1 plus E naught. Why? You know already from height of solids, delta H by H is equal to what, sir? Delta E by 1 plus E naught. Here delta E can be written as what? So here, if you write here, AV can be also written as delta H by H to 1 plus E naught. This is delta H by H, right, sir? Or you can write directly here, delta E by 1 plus E naught is what, sir? Into delta sigma dash. What is delta H by H into delta sigma dash? It is nothing but MV. Just a second, students. MV is equal to what, sir? We have delta H by H into delta sigma dash, right? Now, what is delta H by H here? We can write it as delta E by 1 plus E naught into delta sigma dash, right? What is delta E by delta sigma dash? You can write it as AV. So, MV can be written as AV upon 1 plus E naught. This is the another case they can ask you, my dear students. So, these formulas should be very clear when you are calculating the settlement. And remember, my dear students, when you calculate the settlement, you are always calculating the settlement of clay layer in consolidation. Okay, now there is another concept called degree of consolidation. Sir, here, my dear students, when they ask you what is degree of consolidation here, degree of consolidation is given as U, that is settlement at a time by ultimate settlement into 100. This is degree of consolidation. What's our settlement at a time by ultimate settlement? Here you should know one thing, sir. There is another factor called time factor. Time factor is nothing but TV is equal to CVT upon D square. What is CV? Sir, actually, according to Terjaghi's theory, the rate of change of pore water pressure with respect to time is proportional to the rate of pore water pressure with respect to the depth. So, in this case, what we have derived is dou U by dou T can be written as CV into dou square U by dou Z square, where Z is the depth and T is the time. Here, my dear students, when I talk here, the CV is nothing but the coefficient of consolidation. CV is what, sir? The coefficient of consolidation. What is CV here? CV is nothing but the coefficient of consolidation. So here when I talk about the coefficient of consolidation, CV can be written as K upon MV into gamma W. Okay. Here understand, my dear students, K is the coefficient of permeability, MV is the volume compressibility. Here T is the time taken for consolidation. Here D can be taken for single drainage, thickness of clay layer. For double drainage, it will be H by 2. This is for what, sir? Single layer. This is for what, my dear student? This is for double layer. Agree? Now, my dear students, based on this, they will tell you for same degree of consolidation, time varies with respect to depth, means drainage conditions. From this, if they can also write T1 by T2 can be written as for same degree of consolidation, D1 square upon D2 square. Like that, we have to derive the relations. And remember, my dear students, here, time factor, if it is 50, you can directly remember this value as 0.196, or nowadays they are giving, sir, if degree of consolidation is less than or equal to 60. Time factor TV is given as pi by 4 into mu percentile by 100 whole square. This is the time factor formula for what, sir? When degree of consolidation is less than 60. If the degree of consolidation is more than 60, it is given as the formula 1.781 minus 0.933 into log 10 into 100 minus u percentile. This is the degree of consolidation formula in case of when the degree of consolidation is more than 60. I hope you are clear with the concepts related to the consolidation, right, my dear students? Here, one more thing, my dear students. When I talk about the consolidation, here we have talked about degree of consolidation, coefficient of consolidation, but we also have to think about the immediate settlement also. There is a concept called immediate settlement. The formula for immediate settlement is given as the formula Q is the intensity of pressure, that is B, into 1 minus mu square upon E, where mu is the Poisson's ratio, E is the Young's modulus, Q is the into influence factor. This influence factor is for rigid fitting and for flexible fitting. It depends on L by Z and B by Z ratios. Okay, so please write down this, my dear student. Now, before concluding this session, students, I just want to give you an insight about the other important thing like plastic means I want to discuss about the indices here, which is also one of the important, sir. So here when I talk about the indices here, just a second, students. Here if I talk about the indices here, okay, here my dear students, here we have, this is called shrinkage limit, this is plastic limit, and this is liquid limit. Okay, here we call this as liquid state, this is plastic state. Okay, this is solid state, this is semi-solid state. So my dear students, when I ask you what is shrinkage limit, it is the maximum water content up to which any further loss of moisture does not cause any change in volume. Means after if you cross shrinkage limit, up to shrinkage limit, the volume is constant. What is plastic limit? It is the minimum water content at which the soil can be rolled into 3 mm diameter without breaking. What is liquid limit? It is the minimum water content at which the soil has small shear resistance. Means when you cross that state, it will be in liquid state. So here if I consider here, this is the volume at plastic limit. This I'll take it as dry volume. And here I take this as liquid limit volume. Now my dear students, if they ask you here, what is shrinkage limit? Here if they ask you, what is shrinkage limit? Shrinkage limit E can be written as, or WS can be written as E upon G. This is the formula for shrinkage limit. Still we have another formulas related to dry sample, wet sample and finding the difference. And you should know weight of water is always equal to gamma W into volume of water. Next, what is shrinkage ratio? We have another important thing is shrinkage ratio. What is shrinkage ratio means? Here, see, understand students, volume change expressed in terms of dry volume to the corresponding change in water content. So what's sir? Shrinkage ratio means volume change, YL minus VP, volume change expressed in terms of dry volume to the corresponding change in water contents. This is nothing but, there can be different cases because along the slope it can be same. It can be written also as Vp minus Vd upon Vd into Wp minus Ws. Here there can be Vl minus Vd upon Vd upon Wl minus Ws. Sir, they can ask you, they can give you different values and they can ask you what is the state of the soil. And remember, my dear students, liquid limit is always greater than plastic limit greater than shrinkage limit. This also please keep in mind. And here, my dear students, let me tell you, shrinkage ratio can also be written as mass specific gravity at dry state. Or you can write shrinkage ratio as nothing but gamma d by gamma w. Okay, sir. Now, my dear students, this is what's our shrinkage ratio. What this part, only this part we have now. This we call it as volumetric shrinkage. This we call it as what, sir? Volumetric shrinkage. So what is volumetric shrinkage here, my dear students? Volumetric shrinkage is nothing but the volume change expressed in terms of dry volume to the corresponding, we should say, sorry, again I'll repeat, volumetric shrinkage means volume change expressed in terms of dry volume. That is nothing but what, sir? That is nothing but volumetric shrinkage. Remember, my dear students, how the question, and always remember, there are some important indices also we should know here. Like what is plasticity index, which is WL minus WP, toughness index, IP by IF. IF is known as what, sir? Flow index. Here, what is flow index? You can say W1 minus W2 upon log of N2 by N1. This is flow index. Now here, when I talk about consistency index, WL minus W by IP. Liquidity index, W minus WP upon IP. And remember, my dear students, here, IC plus IL is equal to what, sir? 1. IC plus IL is equal to what? What is IC? Consistency index. What is IL, sir? Liquidity index. Here IT is what, sir? Toughness index. We also have shrinkage index, which is 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 equal to WP minus WS. Okay. So these are the important indices we should know. In addition to this, you should also have an idea on activity ratio, sir. What is activity ratio means? It is the ratio of plasticity index to percentage of clay fraction. Sir, why we want to learn about activity ratio is the swelling and shrinkage index of a soil can be remembered by activity ratio. If the activity ratio is less than 0.25, we'll take as low active, 0.25 to 1.25 as medium active, more than 1.25 it is highly active. Remember, sir, Mont Morlet has a value up to 4, which is the very highly active soil, my dear students. So, my dear students, if you show more and more interest, these sessions will be conducted. As I told you, if you want to join in connect with the IMS Gate Academy, you can just click on the link in the description. Just click on the description link. You can join in the Telegram group. In the Telegram group, every day we'll be conducting daily quizzes. We'll be giving you all the updates on job notifications or YouTube notifications. And we also have Gate Zero Fee program. It is a completely free access of 50 plus hours of classroom. And we'll have all the test series part, chapter test like that for limited access. So whoever is interested, my dear students, just click on that link and join our session. I hope this session will create an awareness on the topics earth pressure and how to calculate the settlement and how do we calculate shrinkage limit, plastic limits and all. I hope this video will help you. Thank you.